Hello, with the help of my students, we're going to show you that there are cases where you can tell the prescription of an eyeglass lens from just a photograph.
All right, Doc, say action.
Action! My student Vlad is using his smartphone to photograph Merritt, who is facing him, and Danny, who is in the middle. But Vlad's challenge is to arrange for Merritt and the virtual image through Danny's eyeglass lens to be both in focus. The magic distance for the eyeglasses Danny has on is 50 centimeters. This photo shows the general idea. See the virtual image through each eyeglass lens. There is a left hand placed at the distance of the virtual images so that the hand and virtual images are both in focus. The distant objects outside the lenses are blurred. These glasses are strong, placing virtual images only 20 centimeters from the eyeglass lens. But we need a subject better than the hand so that the overall scene has enough clues for another student to estimate the distance from the eyeglass lenses to the subject. This distance will also be the same distance that the virtual images are from the lens, and from this estimate we can arrive at the eyeglass prescription. The distance from the lens to the virtual images of distant objects is the focal length. The prescription in diopters is obtained by dividing the centimeters of this distance into 100 and including a minus sign since the lens is a diverging lens. Here's an example. We need to estimate the distance from the lens to the small virtual image of the letters from the distant wall. The key is to estimate the distance from the lens to the lady, since the camera is focused on her as well as the virtual image. This distance is about 50 centimeters. Think about how far you would be from someone having a nearby private conversation. The prescription for the eyeglasses is then -2 diopters. That's quite impressive, getting a prescription from just looking at a picture. But it's only possible because both the virtual image and the main subject happen to be at the same distance from the camera. We are outside here, and the distant object we're focusing on is a banner at my university. You can see in this detail of the photo that the letters are quite blurred when not seen through the lens. I would like to thank my students Merritt Tutwiler and Danny Secor for their roles in this demonstration, and also thanks to Vladislav Rakowski, the photographer and videographer.